What's going on, people? Mr. Owens here. Thank you all so much for sending all your work in yesterday. It was really good. And yeah, it was fantastic. We're not quite up to the 80% level in each class. So if you're looking at this and you want to see Mr. Owens doing a silly dance, then make sure you send your work in because we need 70% from each class, okay? Today's lesson is all about problem solving using units of measurement for time. Okay, it's going to be a fantastic lesson. Enjoy it, and please make sure you send your work to year5 at grange.harrow.sch.uk. No, year5 at Harrow, year5 at grange.harrow.sch.uk. Yeah, that is right. Goodbye, people. Have a good lesson.
Right, so what are you going to need for the lesson? You're going to need something to write with and paper. And as I always say at this point, if you do not have these things, please pause the video, go and get them as they are very important for today's lesson, and then come back when you are ready to continue. Excellent. So, what is your LI today? Your LI today is to convert between different units of time to solve problems. And guess what? I've even got this lovely fancy display screen for you today, which is lovely if I do say so myself. So your first task is to write the LI and the date at the top of the page. So please pause the video, complete that task, and then press play when you are ready to continue. Excellent. And look, I've even got this fancy success criteria display for you. I am on top form today. So success criteria, remember, steps to success, steps to achieving our objective. So what is your success criteria? I know the units of measurement for time. I know how to convert between these units of measurement. I can convert between the units of measurement of time to answer problem solving questions. Excellent. The next thing we're going to do today is a recap. Remember, recap's very important to strengthen our understanding. So here are your 4 questions. How many months are there in a year? How many months are there in 2.5 years? How many seconds are there in 2 minutes? And how many weeks are there in 30 days? So please pause the video, complete that task, and then press play when you are ready to continue. Excellent. Welcome back, people. So in a year, okay, we have 12 months. January, February, March, April, May, June, July, August, September, October, November, December. Have I said that right? Have I missed one? October, November, December. Anyway, it's 12. How many months are there in 2.5 years? Okay, now in 1 year there are 12 months, so in 2 years there's going to be 24 months. Okay, but we want to know how many years they're in, and then we've got an extra half of the year, and half of the year, half of 12 is 6 months. Okay, so then you just do 24 plus the 6, which equals 30 months. Okay, next question was how many. Oh, there's a plane going by, so I'll stop there whilst the plane goes by. I think it's a helicopter actually. It's very loud. Sorry about that. How many seconds are there in 2 minutes? Okay, in 1 minute there is 60 seconds. So in 2 minutes you just times that by 2. So 60 times 2 equals 120 seconds. And then the last question was how many weeks are there in 30 days? Okay, now remember, a week is 7 days. So the month of June has 30 days. So I thought this would be helpful. So I've marked out each of the 7 days. So first 7 days, that's 1 week. Next 7 days, that's 2 weeks. Next 7 days, that's 3 weeks. Next 7 days, that's 4 weeks. And then we've got 2 left over. So it would be 4 weeks and 2 days. Now, hopefully most of you got that absolutely right. If you didn't, don't worry. Maybe look over the videos from the last couple of days or send me an email so I can give you some one-on-one support. This is your starter. What do litres measure and what do grams measure? So please pause the video, complete this task underneath the recap, and then press play when you are ready to continue. Excellent. So litres measure volume, okay, and the volume being the space that the liquid takes up in any kind of container or whatever it's in. And then the grams measure mass, okay, and the mass of something is the amount of substance in it. Okay, so for example, I don't know. For example, I don't know. I think the one I used before was a PlayStation. So the mass of a PlayStation would be the amount of substance or matter which makes that a PlayStation. Yeah, excellent. So we're now going to move on to our lesson today, which is all about problem solving with units of measurement, especially with time. Okay, and look again, I've got this lovely fancy screen for you. So there's no excuse to not have a good lesson. Right. So problem solving. Let's go for a question. 3 children are running a race. Whitney finishes the race in 3 minutes and 5 seconds. Eva finishes the race in 192 seconds. And Alex finishes the race in 2 minutes and 82 seconds. Who finishes the race first? Now. Okay. We are going to use exactly the same process to answer this question that we have with all our other problem solving lessons and questions. The 5 steps. I call them the 5 steps to freedom. And they're called the 5 steps to freedom. I've just literally called them that now. And the reason why I'm going to call them the 5 steps to freedom is because once you complete it, a problem solving question using these 5 steps, you will feel free. Well, I hope so anyway. Anyway, enough of that as a sidetrack thought. So, right, we're going to follow the 5 steps. Step 1 is to read the question. So let's all read the question again. 3 children are running a race. Whitney finishes the race in 3 minutes and 5 seconds. Eva finishes the race in 192 seconds. Alex finishes the race in 2 minutes and 82 seconds. Who finishes the race first? Excellent. What is the question asking you? The question is asking you, or us, as we are doing this together now. The question is asking us who finished the race first. Okay, so I know what the question is asking. It's asking out of Whitney, Eva and Alex, who finished the race first. Now, what is the problem? The problem is that it's hard to know because this is in minutes and seconds, this one's in seconds, and this one's in minutes and seconds. So it's hard to compare them. Remember before when we had all those fractions with different denominators, it was really hard to compare them. It's the same kind of concept here. Because they're all in different units of measurement, it's hard to compare them. Right? So, step 4 is how can we solve the problem? We can solve the problem by converting all the times into seconds, and then we can easily compare. Now, so what I'm basically suggesting here is that we turn this into seconds, these are already in seconds, and turn this into seconds. And once they're all in seconds, it will be easy to compare. Now, what you could do, an alternative way, it's up to you, is you could just convert them all into minutes. So these are already in minutes and seconds, so you could just convert this into minutes and seconds as well. Okay, but the only slight problem is here, there's not even a problem actually. The reason why I would suggest converting these into seconds is because the numbers are quite small, so it's probably just easiest to convert them into seconds. But say for example you've got like 12 minutes, you're going to have to be doing 12 times 60, or yeah, I don't know, it just get quite complicated. So what I would suggest doing is just converting them all into seconds when the minutes are quite low, but when they start getting up to 12, 13, 14, I'd probably just start converting everything into minutes. It would probably be a bit easier. So, hope I didn't confuse you there. Right, so step 4, how can we solve the problem? We can solve the problem by converting all the times into seconds, okay? And then step 5, let's just say step 5, but it doesn't say step 5. Step 5 is to solve the problem. Okay, so Whitney takes 3 minutes and 5 seconds. So 3 minutes is each minute is 60 seconds. So we've got 3 minutes, it'll be 3 times 60. So we've got 180 seconds. And then we've also got the 5 seconds, so we're going to add the 5 seconds on. So we have 185 seconds. So Whitney finished the race in 185 seconds. Eva, we already know it's already in seconds. She finished 192 seconds. Now Alex finished the race in 2 minutes and 82 seconds. Now, remember, each minute is 60 seconds, and we've got 2 minutes. So 2 minutes should be 2 times 60, which is 120 seconds. Then we've also got 82 seconds over the top of that. So just add 82 to 120. That will give us 202 seconds. Okay, so then we've now got 185 seconds, 192 seconds, and 202 seconds. Now, it is very easy, okay, to compare them because they're all in seconds. So whoever's the smallest, whoever did it in the smallest amount of seconds is the quickest, finished it first. And the smallest is Whitney, who did it in 185 seconds. So there you go, that is your answer. Okay, it's not that difficult, right? And that's that. So we're now going to do another problem, but this time you guys are going to do it with me, okay? So this is the problem. 3 teachers ran a race. Mr. Olin finished in 2 minutes and 2 seconds. Miss Halim, or Mrs. Halim even, finished in 182 seconds. And Mr. Kerbal finished in 1 minute and 82 seconds. I want to know who finished first and who finished last. So we're going to go through each step. Okay, you're going to do it and then I'm going to go through it with you. Okay, and we've done this before, so hopefully you'll know what I'm talking about. So step 1 is to read the question. So everybody please read the question. Okay, I'll just read it as well. So 3 teachers ran a race. Mr. Olin's finished in 2 minutes and 2 seconds. Mrs. Halim finished in 182 seconds. And Mr. Kerbal finished in 1 minute and 82 seconds. Who finished first? Who finished last? Step 2, what is the question asking you? So, guys, what do you think the question is asking you? Pause the video, write it down, what you think the question is asking you, and then press play, and we will go through this. Excellent. So the question is asking us, or you, however you want to phrase it, okay, who finished first and who finished last? So out of Mr. Kerbal, Miss Halim, and Mr. Olins, who finished first and who finished last? What is the problem here? Okay, guys, so now you need to think about, right, what is the problem? So please pause the video, write down what you think the problem is, and then press play when you are ready to continue. Excellent, welcome back. So what is the problem? Okay, the problem is that the times are in different units of measurement. Okay, so if you look here, these are in minutes and seconds, these are in seconds, these are in minutes and seconds. So the easiest thing to do, okay, the problem here, sorry, not there, jumping ahead of the gun. The problem here is that we've got minutes and seconds, so it's hard to compare them. Okay, and then step 4 is how do we solve the problem? So how do you think we can solve this problem? So please pause the video, complete the task, this question, and then press play when you're ready to go through it. Excellent. So how do we solve the problem? Okay, the way to solve the problem is to convert all the times into seconds, and then we can easily compare. Remember, if you wanted to, you could convert them all into minutes, but because these minutes are quite low, it's probably easiest to put them all into seconds. Okay. Excellent. And then we're going to move on to the last step, which is to solve the problem. Okay, so what you're going to do now is you are going to solve the problem. So please pause the video, complete that task, and then press play when you're ready to continue. Excellent. So we need to turn them all into seconds. So 2 minutes, 2 seconds. Remember, each minute is 60 seconds. So you just do 60 times 2, which is 120 seconds. And you've got 2 seconds left over, which is 122 seconds. So Mr. Olin's finished in 122 seconds. Would you know Miss Halim finished in 182 seconds? Then Mr. Kerbal finished in 1 minute and 8. Pardon me. Sorry, that was very rude. Mr. Kerbal finished in 1 minute and 82 seconds. So to work that out, remember each minute 60 seconds, so you just do 1 times 60, which is 60 seconds, then you've got 82 seconds left over, so you do 60 plus 82, which equals 142 seconds. Okay, so Mr. Olin finished in 122 seconds, Miss Halim 182 seconds, and Mr. Kerbal 142 seconds. So who finished first? Remember, it's the shortest amount of time, or the small, so that'll be the smallest number. So obviously Mr. Olin's finished first. Like, were any of you ever in doubt? Miss Olin's finished first. And last, Miss Halim was the slowest. Oh, I think I've got it. There we go. Look, Miss Halim's crying because she came last. Oh, how sad. Anyway, so that is how we answer our problem. Now, what you guys are going to do is you're going to go away and solve your own problem. So, superstars. This is your problem. Jane bakes a cake for 3 minutes and 20 seconds. Sam bakes a cake for 3 minutes and 20 seconds. Dawn bakes a cake for 120 seconds. Who bakes the cake quick? Their cake. It should say their cake. So, who bakes their cake? Who bakes their cake quickest? And who bakes their cake slowest? And here are your steps, which I would strongly advise using to go through them. Okay, so please pause the video, complete that task, superstars, and then press play when you're ready to go through these. Excellent. So Jane baked her cake. So what you needed to do really there was just convert them all into seconds. That's probably the easiest thing to do. So 3 minutes and 20 seconds is 200 seconds. 2 minutes and 20 seconds is 140 seconds. And then we already knew Jane's cake was 120 seconds. So the quickest one would be the smallest number, which is Dawn. So Dawn baked her cake the quickest. And who was the slowest? That would be the biggest number. And that was Jane. Okay, superstars, I'm sure most of you got that right. If you didn't, don't worry. Look over the video again or send me an email for some extra support. Now, superstars, that is your lot for today. If you'd like to do the blue zone task, that would be good. If not, don't worry. And please send me your work and I shall see you tomorrow. Goodbye, superstars. And then we should have the blue zone. Blue zone, this is your problem. 3 children kick a ball in a park. Harry kicks a ball for 12 minutes, 70 seconds. Sally kicks a ball for 720 seconds. And David kicks a ball for 11 minutes and 102 seconds. And these are your questions. Number 1, rank the children in order of how long they kicked the ball from shortest time to longest. And the next one is, what is the total amount of time the children kicked their balls in minutes? Okay, so please pause the video, complete that task, and then press play when you are ready to continue. Right, let's go through the answers then. So when you approach the question like this, hopefully you use the 5-step method. But essentially what the question's asking you to do is to convert everything into the same unit of measurement, because you've got minutes and seconds here, you've got minutes and seconds here, seconds and minutes and seconds. So it's hard to compare them, okay? It's going to be very difficult to know who kicked their ball for the shortest time or the longest time when they're all different kind of units of measurement. So the best way to do it is just to convert them all into either seconds or into minutes. Now, I've decided here to convert them all into minutes because the numbers are quite high. So you're going to have to be doing things like 12 times 60, which I'm sure most of you can do, but it's probably just easier to do it like this. So, but obviously, if you did it the other way and you got the same answer, then it doesn't matter. Right, so anyway, so 12 minutes and 70 seconds, okay? The only thing I've done here is 70 seconds, within 70 seconds there's a minute, because remember a minute is 60 seconds. So there's actually 13 minutes, and then you've got 10 seconds left over. So that was that one. 720 seconds is 12 minutes. There's many ways you could have done this. You could have done 720 divided by 60. That would have told you how many minutes it is. Or if you knew that 12 times 6 is 72, then you would know that 12 times 60 is 720. Okay, so you could have done either way. And then David kicks the ball for 11 minutes and 102 seconds. So again, within 102 seconds, you've got a minute. So that would be 12 minutes, and then you've got 42 seconds left over. So David kicked his ball in 12 minutes and 42 seconds. Okay, now the question then asked, okay, rank the children in order of how long they kicked the ball from shortest time to longest. So Sally kicked her ball for the shortest amount of time, which is 12 minutes. David kicked his ball for the next shortest amount of time, which is 12 minutes and 42 seconds. And then Harry kicked his ball for the longest time, which was 13 minutes and 10 seconds, okay? Then the last question was like, what's the total amount of time the children kick their ball in minutes? So then you just got to add up everything, and that came to 37 minutes and 52 seconds. Excellent, blue zone. As I said to superstars, if you struggle with that, don't worry about it. Okay, maybe just watch the video again or send me an email and I can give you some extra support on that. Right, your challenge today is this. Teddy's birthday is in March. Amir's birthday is in April. Amir is 96 hours older than Teddy. What dates could Teddy and Amir's birthday be? Okay, this is quite challenging, I'd say, but I'm sure all of you are going to get it correct. What I would advise is using the 5-step process. If you think you can do it without it, that is absolutely fine, but I would just suggest using that. Right, have a fantastic day, blue zone, and if I've got any superstars, you as well. Please send your work to year5 at grange.harrow.sch.uk. Have a fantastic day, guys, and I shall check in with you tomorrow. Bye.